So today we are doing the 0625 paper 4 from March 2023. This is paper 4 variant 2. That's the only variant available for this session. That's the extended theory paper. Let's get started. Okay. A boat crosses a river. The boat points at right angles to the riverbank and it travels at a speed uh, of 3.5 meter per second relative to the water. A river current acts at right angles to the direction of the boat points. Right? The river current has a speed of 2.5 meter per second. By drawing a scale diagram or by calculation, determine the speed and direction of the boat relative to the river bank.
So we have to calculate the speed. The resultant speed is like the hypotenuse of the triangle formed by the board speed
Mhm.
and the river speed. So we usually use the Pythagorean theorem, if I'm not wrong.
Okay. So a boat is crossing the river, right? And it is at right angles to the river bank. So let's say, right, this is the river bank, and this is our boat. Excuse my drawing, right? And it's
Yeah,
moving this way, right? And you have the river flowing, right? So all the water going, and its current is at right angles to the direction the boat is pointing, right?
yeah.
So this is 2.5 meter per second, and this is 3.5, I believe.
Okay. Yeah,
Right? And so the resultant will obviously be this one.
yeah. We're gonna um, v squared b plus v squared r. Yeah, that. So it's
And
gonna
what are we
be
getting out of this?
625 plus 2.25.
Hmm?
6.25 plus 12.25, and when we add that, so under root 18.5. And then it's gonna be 14.3 meter square.
4.3
Meter square, yeah.
meters squared, no, not meter squared, 4.3 meter per second. That's the resultant speed,
Yeah, sorry.
right? So we have 4.3 meter per second. Now, all right, next question. Speed is a scalar quantity and velocity is a vector quantity. State the names of one other scalar quantity and one other vector quantity.
Yeah.
Yeah?
Yeah. So it's gonna be magnitude.
No, no. Tell the quantity. They're not asking you to define what a scalar is.
Oh, okay. Mass
Yes.
or distance. Mass or distance.
Mass is a scalar quantity. What's a vector quantity?
Force.
Force. Okay. Figure 2.1 shows a ship loaded with containers. The ship is made of steel. The density of steel is 7,800 kilograms per meter cube, and the density of water is 1,000 kilograms per meter cube. Explain why the ship is floating.
Uh, because the ship is not a solid block of metal,
Yes.
and because it also floats above because it has average density and and what else? Wait. I mean, you only need 2 points, right?
Yeah.
Will the average density work?
Yes. So the average density of the ship is less than water.
Yeah.
Alright, the containers with the greatest mass are loaded near the bottom of the ship. State and explain the effect on the stability of the ship of loading the containers this way.
Yeah. Wait, let me I don't know this one.
Right, so if you have a stack and you've got the heaviest item at the bottom, right,
Yeah.
then you're placing the lighter ones on top,
Yeah.
right? What you're doing is you're lowering the center of gravity,
Okay.
right? Because you learned, remember the experiment they did, they had a can and they placed a weight at the bottom, and so when they tried to tip it over, right, it didn't tip over because the center of gravity, which is technically like also the center of mass in most cases, right,
Yeah.
the lower it is, the more stable the object becomes, right? So having the heaviest containers loaded near the bottom of the ship, right, lowers center of gravity or center of mass, right,
Yeah.
and that increases the stability, right? So the ship is more stable.
Hello.
Yes, hello.
I can't hear you. Yeah, now I can. Your voice was cutting off in between.
Okay. So did you get how that works?
You could you explain from the second point?
Well, if the center of
It
gravity is
is
when the center of gravity is lower for any object, it becomes more stable.
okay.
Basically.
Okay.
Okay, a crane lifts a container 48 meters vertically upwards. The mass of the container is 30,000 kilograms. Calculate the energy transferred to the gravitational potential energy stored in the container.
I have a question.
Yeah.
For the previous question, is it because the weight of um those loads are like stabilizes the ships?
They are, right? So what happens is that uh, there are two things that stabilize something, right? One is having a wide base. So if you place a book on its like that, lying flat, or if you have a book standing, which one's more stable? Like if you tip this, it will quickly follow.
Yeah.
If you nudge this, it's not going anywhere,
Yeah.
right? It has a wide
Yeah.
base. So the wide base is one thing that increases stability of an object. The second thing, as you can see over here, right, can with a rock inside it, is when the center of gravity is lower. The lower it is, the closer it is to the base, right? The more
Yeah.
stable it is,
Okay.
right? So when you are loading the heaviest containers near the bottom of the ship, means that's as low as it can be towards the base of the ship, right? And so that makes it stable. Have you seen those toys where they have like a round bottom and right? If you try to tip them over, they just come back.
I think so. Yeah.
Right? If you ever notice, their base is very heavy.
Yeah.
Right? Now the reason they come back is because the base is circular, and that's the trick of it. But what gives them stability is the weight that they add to the base.
Yeah.
Okay, so if you have like object with a flat base and you try to tip it over, it's heavy near the bottom, right? Obviously, it's not going to roll back and forth. It just won't tip over easily. You need to apply much more force, tip it over, as opposed to if you have something that, right, is either has its weight evenly distributed or has the weight more towards the top. This one's easier to tip over,
Yeah.
right? In fact, in some cases, this would be called unstable.
Okay. Yeah.
Okay. So, what
Okay.
about this question? A crane lifts a container 48 meters vertically upwards. The mass of the container is 30,000 kilograms. Calculate the energy transferred to the gravitational potential energy stored in the container.
Okay.
Right? So, what is the formula for gravitational potential?
So you're already
Your voice is breaking up.
I can't hear you.
Yeah.
Hello?
Yes. Hello.
Yeah. Um. Yeah.
Yeah. So, how are we going to go about solving this?
We need to find. We need to calculate the um gravitational potential energy, right?
Hmm.
We need to find the gravitational potential energy, right?
Yes.
So mass multiplied by um g multiplied by h. Is that correct? Yeah. So mass is 30,000 kg. The height change is 48.
So, what are we getting out of this?
Uh, Wait, let me just take a look at this. 14112
Hmm.
Uh, it's a big number, so it's gonna be 14112
14,112,000.
Yeah,
Right? So this is like 3, so that makes it kilo, and that makes it, right? So we could say 14 megajoules or like 14.1 megajoules, right? Or
yeah,
we could say 1.41 into 10 to the power 7.
yeah. Okay, okay.
Alright?
Yeah,
Right, question 3. State the principle of conservation of energy.
Just uh, I think this is based on memory.
Yes, it is based on a very basic concept, but yes, conservation of energy.
The is it I think I remember usually the like states that the principle of conservation of energy states that energy cannot be created or destroyed. If I'm not wrong.
That's only half of it.
Okay, let me dig in more. Bit. Mm, I don't know the second one. I think it's transferred um, from one thing to another
One thing
or object.
from one store.
Yeah,
All right, a wind turbine has a maximum output of 1.8 megawatts. The turbine operates at a maximum power of 4 hours. Right? Define the unit kilowatt hour.
okay. It is a unit. Wait. Mm, let me remember this one. Is it like this unit is like equivalent to energy transferred
So yes, it is the energy transferred.
by 1 kilowatt?
Yes, the energy transferred in 1 hour at a rate of 1 kilowatt.
Yeah.
All right, calculate the energy produced by the wind turbine operating at maximum power for 4 hours.
So power multiplied by time.
All right,
You
so
have
the
to use
first
that,
thing is that is it's 1.8 megawatt, right? Which
which is the
means
energy, right?
this,
Yeah.
which means it is 1800 kilowatts,
Yeah.
right?
Yeah. So
Right.
we gotta multiply that with 4.0.
And what are we getting out of that?
7200.
Hmm?
7200.
So 7,200 kilowatt.
Yeah.
Radiation from the sun is the main source of energy for most of our energy resources. State two energy resources that are not radiation from the sun.
Wait, let me think. Mhm. Uh, Nuclear energy?
That's one. What
Mm,
else?
let me think. There is this one word, but I know the meaning of it. I don't remember the word, but like, um, it comes from it produces heat from the earth itself. Yeah, it was geo something. Yeah, geothermal. Yeah.
And there's a third if you're interested.
Oh, okay.
Right. So far, so good. So, next question, figure 4.1 shows a metal pan on an electric hot plate. The pan contains 200 centiliter cube of water. The pan is heated, the temperature of the water in the pan increases. Thermal energy is transferred through the metal pan by conduction. Right? State and explain the two ways that thermal energy is conducted in a metal.
Lattice vibrations.
So one is lattice vibrations. What do they do?
Mm. Oh, particles in the particles in the hotter part of the metal gain kinetic energy and vibrate more. So these vibrations are given to the neighboring. These vibrations are given to the neighboring particles
Yeah. Okay.
from collision.
All right.
Um,
And then the next.
do we need to explain into detail or
No,
just?
no, no, no. This is enough.
Oh, okay. Um, it was electron something. Wait. Oh, free electron something. Or you can say delocalized electrons. Yeah. Is that right?
Right. And it's for 3 months. So we need three. We need three.
We need one more. I don't know anymore.
Okay. So the electron thing, they've actually, divided into 2 points. What they've done is, right, right, electrons move through the metal, colliding with, carrying energy, colliding with.
Also, yeah, basically explain it a little, right? Briefly.
Yeah.
So wait,
So,
we either brief one of them, right?
so what they've done is that they've treated the free electrons separately, and then they've treated the electrons carrying energy from one part of the metal to the right throughout the metal, the other parts of the metal as a separate point. So
Why?
I don't know, but that's what they've done. Right. So what they mean to say is one is that you've got electrons going from here to here, right, and then you've got electrons right coming in and colliding with particles to raise their energy, and then you've got the lattice vibrations.
Yeah.
Those are three things.
Okay.
So in a case like this where you think, oh, it's only 2 points, but it's actually worth more, and so you give a bit of detail that would work.
Okay. So either one of any one of three, you can briefly explain it.
Well, that's kind of a hit or miss, I would say, right? Because if you were to go on to explain the lattice vibrations, you're not going to get another point. They've actually treated the electron movement as two different points. not the lattice vibrations. So if you went on explaining lattice vibrations, it won't help. Right? So it happens sometimes. It happens sometimes because you don't really know what the examiner like in O level IGCSE. It's usually very straightforward, but sometimes in certain questions they're expecting a bit more, but you don't know which part they're expecting a bit more of. So in those cases, if you feel like in this case, you think, well, there are only 2 points and there are 3 marks, and so what you do, you can give detail for the lattice vibrations and you can give details for the delocalized or free electrons, because delocalized and free electrons are the same thing,
Yeah.
right?
Yeah. Okay.
So what you can do is you can detail both of them, right? Give a bit of detail for this, give a bit of detail for this. That should work, right? So
Okay.
so give a in case of doubt, give a full response.
Yeah. Okay.
Okay, the water boils and leaves the liquid as a gas. Explain in terms of forces and distances between, right? So forces, that's 1 mark, and distances, right? Why the gas occupies a much greater volume than it does as a liquid.
Is it because the gases have weaker intermolecular forces than liquids do? Can
Right.
it be?
So yeah. So
Oh
intermolecular,
wait. You can say. I think there's a better word for it. Negligible. Yeah. Negligible
yeah,
forces of attraction.
intermolecular attractive forces in gases are negligible. Yeah, probably should write that better.
Also, gases are more free to move around randomly and rapidly than liquid.
Right, so the distance is much more. Right, the particles, a gas are much further apart. Okay, state 2 ways in which boiling is different from evaporation.
Evaporation occurs in the surface of the liquid.
So how boiling is different. So you need to focus on the boiling part.
Oh, okay. So I'm gonna say boiling occurs throughout the liquid.
Yeah.
Okay. That was sweet. Does boiling? I think. Can I say it? I'm not sure for this one. But okay, you know what? I'm gonna give it a go. It only occurs at a specific temperature.
That is one of the salient features. Occurs at a fixed temperature. So for a pure substance, the boiling point is always fixed.
Oh yeah. Oh yeah. Okay. Connecting that to melting point and boiling point.
All right. Let's. The water is replaced with 200 centimeter cube of milk. The initial temperature of the milk is 20 degrees centigrade. The boiling point of milk is 95 degrees centigrade. The milk starts to boil when 60,700 joules of thermal energy has been transferred uh, to do it. The density of milk is 1.03 grams per centimeter cube. Right? Calculate the value of the specific heat capacity.
There are so many values. It seems hard.
Okay, first of all, what's the formula for specific heat capacity?
Is it wait, mass multiplied? Okay, you got it.
Right, so C equals to delta E over m delta theta. because they're asking you to calculate the specific frequency.
Yeah.
Okay, that's one thing. So we leave the calculation away. Now, next thing is, right, density equals to mass over volume. Ergo, mass,
Equals to density multiplied by volume.
yes, right, which is 1.03 multiplied by 200.
Oh,
Right, you
result
have the density, you have the volume, and so what will this give us?
206 grams.
Hmm?
206.
Yes. So you
Okay.
have 206 grams of milk.
Yeah.
All right.
Okay.
Now, what is delta theta? Right. You are boiling it, and it was at 20 degrees. So that's 75 degrees centigrade.
Okay.
So coming back here, C equals to 60,700, right, divided by 206 multiplied by 75. Do the math, please.
Okay. Um. I may be wrong, but I'm not confident for this one especially.
Mm,
Okay. 3928.8, and I think we gotta round it up if that's correct.
just a second. So we have 60,700. Since you're saying you're not confident, right? So 3.92. Right, now, one thing sort of like a mistake we've made, right, is we've taken the gram value. So this would be
I was
3.92.
thinking that I think we gotta convert it into kgs.
Yes. So this would be joules per gram degree centigrade, right? But normally it's per kilogram. So what we can do is we can go back and correct that.
So wait, they're gonna give you a wrong if you write it in gram.
Well, if you're alert and you know, like you don't end up writing kilograms over here, then they actually allowed it in the marks, right? But for our sakes, right, better to stick to the standard where like the SI units,
Okay.
right? So we do 0.20, oops, 206. Now what are we getting out of this?
Isn't it gonna be the same thing?
It's
Wait,
going it's going to be different.
3.93?
Oh, why is it going all haywire? 0.206. No,
What? What is it
it's
gonna
going
be?
to give you 3,928.
Yeah, the earlier answer, which I said, yeah, okay.
And now it will be joules per kilogram degree centigrade.
Yeah. Okay. Do we have to round it up?
No, you do not
Uh,
round this up.
I mean, it says give your answer to three significant figures.
Huh. Well,
Okay.
what do we do if we're getting a value that is in four significant? So we can treat that as sort of a hint, because the only way we can get this into three significant figures if we use the gram value,
Oh, okay.
right? So that would be over 206 into 75, which was 3.93 joules per gram degree centigrade. And so that's three significant figures. So, right, I guess we could take that as a hint that you're supposed to get it in grams. Although it's sort of confusing. Why? Because what we've learned is to deal with SI units, right? So, what like a student would be trained, right? A teacher would tell the student always convert it to kilograms, right?
Yeah,
Because the specific heat capacity is given as joules per kilogram degree centigrade, right?
yeah,
And so you're getting a value that is 4, right? Even if we round this up, what are we going to round this up? Are we going to round this up to 3930? That's four. That's still four significant figures. Are we going to round this up to 4000? That's still four significant figures,
yeah.
right? So I say that the instructions are confusing, but the mark scheme is allowing for this, so we're good.
Okay.
And I guess we'll stop here.
Oh, okay.
We're halfway through the paper,
Hang on.
right? So we'll complete this the next class, and
Okay.
then the last class that we have, we'll sort of briefly go over the ATP,
Okay.
right?
Yep.
Okay, then.
Okay then. Allah Hafiz.
Class. Okay, so 1 mole is 24 dm cube, right? And so 72 dm cube is 3 moles, right? Which means you need 3 carbons, which is propane.
Yeah.
Okay, the structure of organic compound X is shown. What is X?
See, math is one or two.
Hmm? Meth
Math
is
is
1.
one or
Meth is 1.
two.
So you're going with C. What about you, Sobia?
Same.
I'm playing with B.
Okay, so the naming is confusing, right? So when you're drawing the structure, you draw the acid part first and the alcohol part second. But when you're naming it, you're going to name the alcohol first and the acid second. So the alcohol is 1 carbon, that's methyl, and the acid is 2 carbons, so that's ethanol. See? Okay?
Yeah.
What is the structural formula of the compound formed in the addition reaction of propene with bromine?
What's the general formula for alkene?
CnH2n.
Okay.
In
A.
case of,
Propene is 5.
so this is what propene would look like. Or the other way around. Right? Point being that you're going to get one bromine on the first carbon and one bromine on the second carbon. Right? If you flip this around, so that's what you're getting. You're getting one bromine on carbon number 1 from the other side, and then one bromine. Right? You're not going to get both bromines. Obviously, C and D are completely out. Right? And 1, 2, and 3, and yeah, so it's not going to be scattered to the ends because that's not how double bonds work. So you're going to get A. Ethanol is produced industrially by fermentation and also by a catalyzed addition reaction involving steam. Which row describes one advantage of each process? Hmm?
Is it A?
Aram? Any guesses, Aram?
It would be B.
B,
B.
C, D. Which one?
B.
This one, right? The reactant used is renewable and it requires little energy. So you're both agreeing on the reactant used being renewable,
Yeah.
right? So it would be A,
Yes.
right? The good thing about the catalyzed reaction is that it's a continuous process, right? It does require energy to break the bond. So yeah. All right. Carboxylic acids react with alcohols when warmed with an acid catalyst. That's the formation of esters. What type of substance is formed? I just gave you the answer.
B.
B.
Yeah.
Oh, look.
Same.
Nylon is formed by condensation polymerization. Which structure represents nylon?
Can you help us with this one? Help it.
Okay, so right, what happens in nylon is that you are using a dioic acid and a diamine, right? Which basically means you're using a molecule that has the carboxylic acid group on both ends, and you are using a molecule that has the right NH2 group on both ends. So when you put these two together, right, what you can see over here, the problem with A is it's a single molecule that has the carboxylic acid and the amine, right? And so this is basically a peptide. So this is a protein, right? It's not nylon.
And why is like one block shaded and the other one is not?
Huh?
Why is like one block shaded and the other one is not?
Oh, that's showing like the central part of the molecule is different. So there are two different molecules
Okay.
in principle, right? So you could like shade any one of these.
Okay.
The problem with this bonding is you don't see two amide groups linking together. You don't see two carboxylic acid groups linking together. So that's wrong, right? What you would expect when these two guys come together, right, is a CO NH bond being formed and water being given off, then that's called a condensation reaction, right? And that's why this is called condensation polymerization as opposed to addition.
So it's C.
Yes, right. The problem with Uh, what's the problem with this
because
one?
C and O are
Yeah,
together.
so you've got C and right, so the acid has only lost it's got both its oxygens left, it's only lost a hydrogen, the amide is, and so basically what they're suggesting is what's lost is a hydrogen molecule, which is not what happens. Okay, so your answer is going to be C. So you need to study, right? And so now the shading makes sense, right? The shaded molecule is the dioic acid, right? And the clear molecule, whatever is the structure, right? We're not concerned with that. It's got amide groups on both ends, and so that's the diamide. Okay, and so you need to know how the bonding works to figure this out. Right? This is a correct molecule. It's just not nylon, right? This is a peptide protein.
Yeah. Okay.
All right. Question 36. Which structure represents the repeat unit of the addition polymer formed from but1ene? Right? So how are we going to solve this? Right? They're telling you the position of the double bond. And so what you want to do somewhere, so let's do it over here. Butene has 4 carbons. The double bond is on the first. Right? You've got hydrogens over here. Oh, too many bonds for carbon over here. Right? Now, what you're going to do, again, too many bonds. So be careful of the number of bonds you're putting in. So what you want to do to make this easier is you just want to focus on the part that has the double bond. And so you're going to write it out like this. This guy has 2 hydrogens. This guy has 1 hydrogen here.
Is it gonna be A?
Just a minute. And then it
Okay.
has this entire part. You're going to clump it together, right? And so it has 2 carbons and 5 hydrogens. And so that's how you're going to represent it. And then you're going to think about, okay, addition polymerization, right? So the double bond is going to break open and it's going to form single bonds on both sides. That's what you're getting. So that's A.
Okay.
All right.
Yeah.
All right. 2 grams of powdered calcium carbonate is added to 50 centimeter cube of hydrochloric acid. Which apparatus is used to measure these quantities of calcium carbonate or hydrochloric acid?
It would
Hmm?
Mm.
Yes?
it would be
A. Yes, Sobia?
Uh, A.
Yes. Calcium carbonates are solids, so you're going to use a balance, right? And so the other option you have, right, it's either a burette or thermometer. Thermometers are not used to measure volume. So, right, burettes are, and so you get A. Chromatography or chromatography. The diagram shows a chromatogram obtained from the colors of 3 different sweets X, Y, and Z. How many different red dyes are present in this? Yes,
Is it a B?
yes. So these two guys are the same, and these two guys are the same, right? And so they count up to how many different red dyes, not how many red dyes in total. And so there's two different red dyes that have been used. A mixture contains sand and an aqueous solution of sodium chloride. Which processes are used to obtain a sample of solid sand and a sample of solid sodium chloride from the mixture? Yes.
Is it gonna be
What?
C?
C.
C. Yes. So the filtration is going to trap the sand, and the crystallization is obviously going to turn the sodium chloride solid. And finally, right, a student tests an unknown compound M, right? The compound produces a lilac flame using a flame test and produces a gas which turns lime water cloudy when dilute hydrochloric acid is added. What is M?
B or B or A.
Huh?
B or A.
B or A?
Yeah.
D?
I
Right?
think
So
so.
whenever you have lime water going cloudy or milky or white, you've got carbon dioxide. And that means you need a carbon. So it's either B or
That
D.
was the B.
Right? Lilac flame is for potassium. Right?
Oh,
So you need to, like, in paper 4, they give you the tests, but in paper 1 and 2, like I said, you need to know the tests. Right? And so what you have is K2CO3, potassium carbonate. All right.
Yeah.
Right. So we're done with another paper 2. And next time, I guess, right? So it's up to you. What would you want to do? Would you want to do a paper 4 or a paper 6?
Which paper have we done least between these two?
Well, we've done one round from the specimen, and now we're doing another round from the March 2023 series. Right, so we've done two paper 2s, one paper 4, and one paper 6.
I think we can go for paper 4.
So the theory
Pardon?
type.
and go with ATP.
So
Yeah.
basically, it's up to me. What we could do is we could take a cursory look at both of them, not doing
Yes.
right. So not necessarily doing each and every question, just looking at the different questions and discussing how to approach them rather than solving them in detail.
Yeah. Okay.
Okay, that's what we
I'm
could do.
fine with either of them, so yeah.
Yeah, so that's what we could do.
Okay.
Yes.
All right,
Okay.
Yeah.
all right then. See you next time, inshallah.
Okay. I love
Thank
you.
you.
Allah Hafiz.
Allah.